So we are discussing about residue theorem. There are two methods. Poles are simple or the poles are of nth order. So if the poles are simple, residue of f of z at the pole A is equal to limit z tends to a z minus a f of z. And if the poles are of nth order, the residue of f of z equal to 1 by n minus 1 factorial into limit z tends to a d raised to n minus 1 by z dz n minus 1 z minus a all raised to n f of z at z equal to a. So let's discuss an example. Let us discuss an example. Find the order of each pole and residue at it of 1 minus 2z by z into z minus 1 into z minus. So നമുക്ക് ഇതിൻ്റെ ആൻസർ നൽകുമ്പോൾ പോൾസ് കണ്ടുപിടിക്കണം. So we are getting denominator as 0, z into z minus 1 into z minus 2 equal to 0. Therefore z equal to 0, 1, 2 എന്നുള്ളതാണ് poles and they are simple poles. നമുക്ക് ഫസ്റ്റ് ഇക്വേഷൻ ഉപയോഗിക്കാം. സോ റെസിഡ്യൂ ഓഫ് എഫ് ഓഫ് സെഡ് അറ്റ് സെഡ് ഈക്വൽ ടു 0 എന്നാണ്. ലിമിറ്റ് സെഡ് ടെൻസ് ടു എ എന്നുള്ള ഹിയർ 0. സോ ലിമിറ്റ് സെഡ് ടെൻസ് ടു 0 സെഡ് മൈനസ് 0 എഫ് ഓഫ് സെഡ്. എഫ് ഓഫ് സെഡിന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. ദെൻ സെഡ് ഇൻറ്റു 1 മൈനസ് 2z ബൈ സെഡ് ഇൻറ്റു സെഡ് മൈനസ് 1 ഇൻറ്റു സെഡ് മൈനസ് 2 സെഡ് സെഡ് ക്യാൻസൽ ചെയ്യും. ദെൻ സെഡിന് 0 എന്ന് കൊടുത്താൽ 1 മൈനസ് 2 ഇൻറ്റു 0, സോ 1 by 0 minus 1 into 0 minus 2 minus 2. So 1 by minus 1 into minus 2 is equal to 1 by 2. Then residue of f of z at z equal to 1. So limit z tends to 1, z minus 1 into 1 minus 2z by z into z minus 1 into z minus 2. So here a is 1. F of z is 1 minus 2z by z into z minus 1 into z minus 2. Z minus 1 and z minus 1 cancel out. Then substituting z as 1. So 1 minus 2 into 1 is 1 minus 2 by 1 into 1 minus 2 is 1 into minus 1 equal to 1. And the next one, residue at z equal to 2. The limit z tends to z minus 2 into f of z. So z minus 2 will cancel. Then 1 minus 2 into 2, 4 by 2 into 2 minus 1 is 1. So 1 minus 4 by 2 is minus 3 by 2. നമുക്ക് മറ്റൊരു എക്സാമ്പിൾ നോക്കാം. Find the residue of f of z equal to z square minus 2z by z plus 1 whole square into z square plus 4. So നമ്മൾ ഡിനോമിനേറ്റർ 0 ആയിട്ട് ഇക്വേറ്റ് ചെയ്യുക. സോ z plus 1 whole square into z square plus 4 equal to 0. Implies z equal to minus 1 2i minus 2i എന്നുള്ള കേസിലൊക്കെ ഡിനോമിനേറ്റർ 0 ആയിരിക്കും. ഇവിടെ നോക്കിയാൽ z equal to minus 1 എന്ന് പറയുന്നത് ഹോൾ ഓഫ് ഓർഡർ 2 ആണ്. z plus 1 whole square and z equal to 2i minus 2i എന്നുള്ളത് സിമ്പിൾ ഓർഡർ ആണ്. സോ residue of f of z at z equal to minus 1 calculate ചെയ്യുമ്പോൾ സെക്കൻഡ് ഇക്വേഷൻ ഉപയോഗിക്കുക. that is limit z tends to a 1 by n minus 1 factorial d raised to n minus 1 by d z raised to n minus 1 z plus 1 all raised to n f of z. So here n is 2. For limit z tends to minus 1, 1 by 2 minus 1 factorial, it is 1 factorial into d raised to n minus 1, it is 1. So d by dz into z plus 1 all raised to n equal to 2. So z plus 1 whole square f of z. So f of z substitute here. Z plus 1 square, z plus 1 square will cancel. Then we differentiate with respect to z. Z square minus 2z by z square plus 4. So limit z differentiation will become limit z tends to minus 1 z square plus 4 into 2z minus 2 minus z square minus 2z into 2z by z square plus 4 whole square. Z in minus 1 substitute that is minus 1 whole square 1 plus 4 into minus 2 minus 2 minus 1 minus 2 minus 1 is 1 plus 2 into minus 2 by 1 plus 4 whole square is 5. So 5 into minus 4 plus 6 by 25 is minus 14 by 25. The residue at z equal to 2y. So here it is simple. Then first equation here is limit z tends to 2y, z minus 2y f of z. Where f of z is equal to z square minus 2z by z plus 1 whole square into z square plus 4 ആണ്. അതിന് നമ്മൾ z plus 2y into z minus 2y എന്ന് മാറ്റിയിരുന്നു. And z minus 2y and z minus 2y will cancel. And we substitute 2y in place of z. And it will become minus 4 minus 4i by 2y plus 1 whole square to 4i. And residue at minus 2y, it is limit z tends to minus 2y, z plus 2y into z square minus 2z by z plus 1 whole square into again z plus 2y into z minus 2y. It will cancel. We applying the limit, we get minus 4 plus 4i by minus 2i plus 1 whole square into minus 4i. So we see another example. Find the residue of the function f of z equal to z square by z plus 1 whole square into z minus 2. So we get denominator as 0. So z plus 1 whole square into z minus 2 equal to 0. So the poles are z equal to minus 1 minus 1 is of order 2 and z equal to 2. It's a simple pole. We calculate the residue at z equal to minus 1. So the second equation is 1 by n minus 1 of factorial into limit z tends to a dn minus 1 by dzn minus 1 into z minus a all raised to n f of z is equal to 1 by 2 minus 1, it is 1 by 1 factorial into limit z tends to minus 1 d by dz of z plus 1 whole square into z square by z plus 1 whole square into z minus 2. Z plus 1 whole square, z plus 1 whole square cancel in. And we take the difference, we will differentiate. It will become z minus 2 into 2z minus z square by z minus 2 whole square. We applying the limit is minus 3 into minus 2 minus 1 whole square 1 minus 1 by minus 1 minus 2 whole square is 5 by 9. And the residue at z equal to 2 is simple. We use the first equation, which is the limit z tends to a z minus a into f of z is limit z tends to 2 z minus 2 z square by z plus 1 whole square into z minus 2. Then applying the limit, which is z square 2 square, which is 4 by 2 plus 1 3 square plus 1 3 square, which is 9 4 by 9.